All right, started.
Yep. Okay, so this is a continuation of a meeting that we had last week on my proposal to add storage capacity tracking into Kubernetes with some specific cases in mind that are currently problematic. Let me share my web browser again, because that's where I have the cap open. So we discussed one cap that has been around for a while, storage capacity constraints for pod scheduling. That basically adds an API that is about some objects that represent available capacity, and it describes how to populate that data, how to use it in the volume scheduler. Some opens that we had from last week were around some questions how to make that cap more general, how to extend the CSI standard specifically, because some of the things for network attached storage are not currently covered by that cap. We identified the need to extend the CSI standard. I think there is a solution. I've added one more section describing that, but it depends on details of how to extend the CSI API. So that would be further work that I hope to postpone after 1.19 if we agree, hopefully, that we do this in 1.19. The goal right now is to identify the path forward, not necessarily implement everything for 1.19. That's clearly going to be impossible. I also see that Michelle had some more comments now on the cap that I'm not sure whether we should go through that here or just continue the normal cap review. I think my preference would be to keep that in the cap in the PR discussion, and use this meeting here to talk about the other two big issues that we identified. One is how does that work in combination with ephemeral inline volumes? The problem with the current CSI ephemeral inline volumes is that they are basically a special case. The volumes aren't really getting provisioned using create volume, and CSI driver needs to be modified to support such volumes. And it also, in particular, it only happens after a pod has already been scheduled to a node, and that all makes it very difficult to do any kind of capacity tracking and advanced scheduling of a pod, because it just clearly isn't designed for that. So the proposal that I, since last meeting, turned into a cap, and it really is work in progress. It just outlines the overall idea, is that we add another volume source in addition to the CSI volume source that we have right now. The new inline volume source would be embedded in a volume source inside the pod spec, and it would just say, if a pod comes along, needs this volume, well, here's a persistent volume claim that you can create, and then creating that persistent volume claim will trigger normal volume creation. That's the underlying idea behind this cap here. And because it's reusing persistent volume claim of normal provisioning, we are basically done as far as capacity tracking is concerned. This new PVC will be provisioned like any other mechanism that we come up with to improve pod scheduling in combination with PVCs will also work for these kind of inline volumes.
I actually like this proposal. There was one thing I was not that sure about, and that was that the scheduler should create the persistent volume claims.
Yeah. It could also be, I guess, a separate controller.
Yeah, it sounds more appropriate.
It seemed suitable because that code runs through the pods and knows that there is such a volume inline. It might be the most efficient way. From an architecture perspective, running some other controller would also work. The relevant part is that at some point we do have a PVC. It is bound to the pod. That's the criteria that tells the volume scheduler that it can proceed with that pod because there is this one PVC that, and the PVC of course must be bound like any other PVC that the pod depends on. Both will work. It's mostly now then a question of deciding where to put that code, whether we want to have a separate control loop or just extend the existing one. I would argue that it should still live in the kube scheduler, because otherwise we end up adding something to the cluster that doesn't exist today, which has all kinds of issues with telling people that no, they need to deploy the cluster differently. I would still keep that control loop inside the kube scheduler.
I think scheduler team will not like that.
Okay.
This needs to live, I think, somewhere else. Either PV controller or a new volume controller.
I'm fine with that.
Sorry?
I got just an idea. So you propose a pod with a new kind of volume in its spec. Could that be a webhook, or not webhook, admission plugin that sees this pod on creation? Could it create a PVC and put the real PVC source to the pod?
That could also work. But then what happens if that PVC, that's actually one of my opens. What if that PVC, that inline PVC spec gets updated? Do we allow that?
No.
Is it no? So a PVC itself doesn't have any mutable fields either in its spec.
Oh, it has. It has size, for example. It has reclaim policy.
I think size is the only one.
Okay.
Well, reclaim policy is another one.
Yeah, we could argue that for inline PVC, we just make everything immutable as a simplification.
Well,
perhaps.
but if it creates a PVC object, if you go and modify it afterwards, you can't really tell if it was inline or not.
Yeah, that's. Oh no, I was thinking of this control loop. If a inline pod, if a pod spec gets updated such that the embedded PVC gets modified, what do we do then in that case? That's what I was wondering. If we only look at it once at creation time, that inline PVC basically is immutable. We don't allow updates to it.
You can make the spec. You can make the spec immutable at the API level.
Yeah, and I think that's what we should be doing here. That then allows us to do what Jan suggested with that webhook, where it basically there's one problem with the webhook. The pod hasn't been created yet, right?
It hasn't been created, and what we don't do in admission plugins, we don't do cross-object checks much. Like you need to check if the pod already exists.
But this would be an admission webhook on pod creation.
Yeah.
Yeah, but
which is fine, right?
Well, the ownership is problematic in that case if a pod object doesn't exist yet.
No, it does. It's coming in on.
Do you have UID of the pod? I don't think so. Maybe you do.
I'm not sure. I think that is because it's mutated. If it's a mutating webhook, it gets called first. If it's it's an admission one. Well, can you create that pod before it actually has been admitted? That sounds odd. I suspect that the pod doesn't actually exist in the cluster. That means you don't have a UID. You might have enough criteria to create the ownership reference without the UID, but this is something that we would have to check.
Yeah.
So yeah, it might be doable to do that in a webhook. The question then comes down to, again, how do we get people to install this if it's supposed to be a core Kubernetes feature?
I was suggesting admission plugin because that's part of Kubernetes.
Okay, so it's built in. Okay.
But I guess we get rejected by API server people because they don't like new admission plugins. and they tell everybody to use webhooks, and then you are in this where we are.
Yeah.
With optional
So
components.
that's why I was thinking that if we do it in the volume plugin code that we have in the Kube scheduler, then we avoid all of these discussions of how to add another component to Kubernetes. We just extend the functionality that we already have in Kube scheduler.
Yeah, but like architecturally, it doesn't make sense for this kind of logic to exist in scheduler.
Yeah. Okay. Yeah, you're probably right. So, but I'm starting to hear that this is not such a bad idea as Saad seemed to think at some point, and we need to figure out some implementation details. But this would be something that we can discuss with other people. I surfaced this idea on SIG architecture, and who was it? The overall concern was of the feedback in general was, yeah, this is a new thing. If you think that the use case is strong enough to change the pod spec, it would be doable, it would be acceptable. And yeah, my proposal is that we pursue that quite simply. I think we need to do something, and this seemed to be the most widely applicable solution to more versatile to more versatile inline volumes. The alternative is to add more and more features to the existing CSI inline volumes, and I think that is just not going to scale. It's not going to be the last issue that we have with the current CSI inline volumes. Missing storage class support might be another one. I really don't want to touch that part of a design and just I pile more things onto it.
Yeah, I agree. I like this proposal. We can talk about the implementation detail, if it is webhook or controller or scheduler.
Yeah.
But the thing I don't like is that it uses something that's called persistent volume for something that's not persistent. But I don't see a nice way around it. Like you create this extra
we should probably at some point, persistent volume claim should have been renamed to volume claim, and that entire problem would be gone. Instead of expecting that this volume is persistent, you just say that this is my request for a volume, and we would be done. But this is now history. We basically are stuck with that name.
Yeah. Okay, I think Saad, you had some comments.
My concern. Yeah, that was that was exactly it.
We can do a V2.
It might not be such a bad idea.
On the other hand, it's just a name. I mean, people will get used to it. And my counter argument is that a persistent volume claim also doesn't imply that the volume never goes away. The life cycle always has been of a volume, has always been tied to the PVC. And this is just a case where the PVC is known to go away at some point, but we still don't know when that is. If a pod just keeps running, so does the PVC. So that's a quantitative difference, but not a qualitative difference compared to how other PVCs get created and deleted, perhaps. It's just a bit more automatic with some built-in mechanism to delete it, but that's the only difference. So I guess I now have the AR to figure out where to implement that thing. And we do have some options. On the other hand, how do we figure that out? If I come up with, say, for example, the idea to run a separate webhook, I can investigate whether that's technically feasible. It depends a bit on the ownership model, whether that webhook actually gets called at a time when we can set the ownership relationship reliably. If that's not the case, then I think that's a dead end.
Like
if
just thinking about how things like deployments or stateful sets are implemented and they set owner refs, it's just done as a separate controller.
yeah. So we could argue that it's another application controller, which would make it part of that cube binary. Would that be acceptable? Well, I can ask.
It's acceptable to me to put it next to PV controller in the same binary.
So PV controller lives where exactly?
It's in controller manager, and it has we have a special directory there.
Yeah. Okay.
Where are all our volume controllers here?
Yeah. Okay. That sounds perfect. I think that's
we have
the right place for. Yeah.
We have protection controllers. We have PV controller. Maybe
Okay.
that's all.
Yeah, that's good feedback. I think I'll look into that, because I'll check webhook, but that has probably, I think it has technical issues and deployment issues. This PV controller and making it control part of that binary, that sounds more promising to me. Okay, so no big objections, I hope. That means we can tentatively move forward with SCAP. I clearly need to spell out more details about timing. Okay, well, let's perhaps talk about the other technical issue of the other technical blocker for provisioning for storage capacity tracking. That was, how do we deal with multiple volumes per pod? Because the current mechanism only works for pods with a single volume. There we have a mechanism in place where the storage system gets asked to create a volume for a certain node. If that works, fine. If it doesn't, the pod gets rescheduled. But for multiple volumes, we may end up with one volume created, another volume getting stuck, and then the pod can't be rescheduled because of the first volume. So we've talked about introducing some kind of reservation system. I think that all falls flat on its face, unfortunately, once you look at actual storage systems, because they don't have such a concept. Even if we add something to Kubernetes, a storage driver probably just can implement it as create a volume and treat that as a reserved space and use that for the actual volume when it's time for that. So the proposal here, the initial of a provisioning rollback cap, basically acknowledge that and just treats reservation of space as, let's create volumes, let's not use them until they are all ready, and basically if something gets stuck during the provisioning phase, delete volumes again that are no longer usable for the pod. Lots of details are missing here. I'm just basically outlining the rough idea, and I think Michelle already had some comments that some things might not work as envisioned, but that's no surprise. I really just threw that down to have something that we can talk about. And personally, my preference would be to focus on that later. I just want to make sure that you all think that this can be made to work and that we therefore can move forward with the other caps. I'm not sure how problematic or how common it really is to have multiple volumes from different storage systems in a single pod. My gut feeling is that it's not that common, but I'm not sure.
For local volumes, one of the use cases that I think a fair amount of people use is they want local disks of different storage classes in the same volume. So they might use SSDs as a caching layer in their application, and then a hard drive for like the real, persistent data.
Okay,
and
so
that was a common use case that came up.
Okay, that is indeed a particular class of applications that will always have multiple volumes. So yeah, that's a good point. That those cases then will remain problematic. I think this is doable. We still need to figure out lots of details of how the protocol between external provisioners and the volume scheduling part will work. We also need to solve the question of how to make that race-free. But I think it's doable. It just needs more thought. And well, still considering priorities, my proposal for 119 would be to move ahead with storage capacity tracking and CSI inline volume, not CSI inline volumes, that's wrong tab. The generic CSI volumes. Do both, or try to get both into alpha in 119, gather some experience with that, and then perhaps for 120, add the other cap for multiple volumes. Does that sound reasonable?
So this was one of the concerns that Tim had when he last reviewed this cap about the recovery process.
Yeah.
So I think it's important that we can come up with a straw man that we are fairly confident can work. It doesn't have to be fully fleshed out, but like we should come up with, you know, like the basic flow, and we should be fairly confident that this is feasible.
Okay. So that means working on all three caps together, getting them all ready. But then the actual work from the 119 would be storage capacity and CSI inline volumes. Sounds good to me. I think that's also doable.
Yeah, it seems like a reasonable way forward.
Yeah. So yeah, go ahead. Sorry.
Oh, sorry. Yeah. So Jan and I have been sort of discussing the rollback, how to potentially do the rollback already, but we've currently exhausted our ideas. But it would be, but I think this is something that we can probably try to spend some more time thinking about.
It would be ideal because you clearly know that area better than I do. But I'm not sure whether I can provide additional ideas, perhaps, but probably you will know better which of those are suitable. If you can take that part and flesh out another cap, or, well, yeah, do PRs into this one here to modify the text, or just provide feedback on what I should write down, that all would be helpful. Because then I'll focus on storage capacity and CSI inline volumes first.
Yeah, that's fine. I will take an action item to try to think about this a little more deeply.
You should loop in Andrew Large. I think he had some ideas around this that he was thinking about as well, on how to do the swap of the PVC and make it unavailable. Like he was thinking about it from a data calculator perspective.
I'm not actually concerned about the swapping part. I'm concerned about the rollback part.
Okay.
Yeah. Okay. Shall we look at, well, we do have another half hour. Do we have any other questions from people who have listened in on the call? Any feedback that you have for SIG storage on these activities? No?
So I think I had one question after the meeting last week when I was typing up the notes. Let me see if I can pull it up. So one of the things that we talked about was, how are we going to do a mapping from storage class to storage pool? And someone on the call suggested we can extend CSI to have a list storage pools call. and then extend get capacity to return the storage pool that a given storage class belongs to. So basically you say, here's my storage class, what it pooled is, and that makes sense.
I think we actually don't need to extend get capacity for this.
Okay.
What we need is this list storage pools. And what that returns is, at least for this particular purpose, the topology of that storage pool. And that's the information that the external provisioner then needs for the get capacity call. It then can just loop over all storage classes, whether they are applicable to that particular storage pool or not, and call the CSI driver for pools that, for storage classes that don't even select the current pool. That's where the CSI driver then just returns 0 capacity, which is a true answer. And the external provisioner then knows that it just can't use that combination of topology plus storage class. And it then won't create entries in the CSI storage pool for that particular combination.
I had a question yesterday that I commented on in the spec, but I'm currently not really seeing the value of having a separate storage pool that's not like having a one-to-many mapping between storage pool to storage class. Like, can we potentially simplify this if we assume there's a one-to-one mapping?
Yeah, we can. Actually, a prior version of that cap recognized that this is a valuable special case for some CSI drivers and had a way to model that effectively. But then I think it was you actually who asked me to simplify the cap and remove that special case. I can just revert and bring back that text. It then would be still the same API, but it would have just one entry for the CSI storage pool with capacity that applies to all storage classes. That was also my original idea, that, yeah, storage class may be relevant for some use cases, but often isn't. And therefore, I wanted to have an API that can efficiently represent both cases. I think what you are now suggesting further down, let me scroll down. Can you still see the screen?
I mean, yeah. I think what I'm suggesting is like not even have a one-to-many.
Yeah, but then we no longer address those storage drivers where the storage class actually does have an impact on capacity.
No, it does. So like you still have, you report a capacity per storage class. It's just you don't have this extra storage pool object that has
so you want to flatten the API further.
Yes.
Okay. I think one objection was that in that case, if we ever end up with the need to represent more information about the CSI storage pool, we don't have a good place to put that. That was the other cap from VMware, where they basically want to have the CSI storage pool or storage pool in general as an object that actually refers to one pool, and where they want to have additional information. It's not in this cap here, but this would be a natural extension of that concept. And then it will become awkward if we just don't have that CSI storage pool at all anymore.
But can we represent, say, health or something on a storage class instead of having a new storage pool concept?
Yeah, but if we have, but then that information, if it's just shared between all, for this case where the storage class actually refers to, or multiple different storage classes refer to the same pool, then replicating health per storage class would be redundant.
Yes, it would. But I think, I guess the main thing is that, like, I'm worried that we are going to create an API that we end up don't really using. and that has not served us well in the past.
Okay.
But only having a storage class but don't have a storage pool, I think if you only have the capacity on the storage class, that really seems odd without a pool concept.
But today, so like, this is basically how the CSI spec is today, right? The capacity is reported per storage class, parameters, per topology. There's no sense of a separate storage pool object. And at least in this proposal, the way capacity is reported, it's reported per storage class anyway. So we're not really using this shared storage pool concept in Kubernetes.
That's true. My worries is a bit that if we indeed have many different storage classes, that we end up creating more data. But the individual objects will be smaller, but we replicate information a lot more in the API server, because every single object then has some, so the topology, for example, will be replicated multiple times in every single object.
I think that's fine. It just, to me, like having these nested structures, I think makes it really hard to sort of understand what's going on and to be able to act on it. And if we can just, like, since we're not actually taking advantage of this structure, I would prefer that we try to simplify it as much as we can.
This is so just, do you mind if I chime in? This is interesting conversation. And I'd like to use use cases. So I'm thinking in use case, right? Storage pool to me is a pool of disks. And then storage class is an abstraction layer that is consuming storage pool, right? So we can set quotas per storage class. And what I'm seeing customers using for simplicity purpose, for exactly the same simplicity purpose, people are creating collection of disks. We call them storage pools, exactly the same name in socket-defined storage. And we assigning those storage pools to storage classes. So the storage pool creation process is done manually by the storage admin. But as I said, for simplicity purposes, they create one storage pool and they give the storage pool to multiple departments within their organization. So hence they have to create multiple storage classes. So today, that's exactly how it works in reality. We have one storage pool with multiple storage classes that are given to multiple departments. And each storage class has different quotas assigned. So those are the use cases I'd like to share. Thanks.
Yeah, I think that strengthens the argument that we need to track capacity per storage class. And no, I don't think there is any doubt about that. The question just then is, do we still need to surface the fact that there is some underlying shared pool that implements those different storage classes? Whether that is useful in Kubernetes at the Kubernetes API level is currently where we are unsure. Xing, do you think that Christian might have an opinion on that? Because I think he wanted at some point, he actually had a separate cap pending where he introduced storage pool as a concept for different purposes. And after some debate, we basically are unified on this API that you see here, CSI storage pool, then capacity per storage class. And he agreed that this would also serve his needs. If we now take away the CSI storage pool from this cap, we are basically back to the drawing board for him, where he needs to come up with something else.
Yeah, I think if it's going back to without a storage pool, then that's not going to work. I think it's just going back to the beginning, just have the storage class. I think there are some use cases he listed in this other cap. You could potentially have, if you can potentially have so many storage classes, and each pool. I think it's. I actually need to look at his cap and find that example.
Yeah, because I think the main thing is that, at least from a capacity point, we are not reporting any shared capacity for a single storage pool. We're still reporting capacity at the storage class level. So like this object is currently not really giving us anything.
Not in this
I
cap.
feel like we need to look at how we're doing a mapping between this and the CSI, and maybe need to see how we can introduce the storage concept in CSI and then map them. I need to I need to take a look of that.
Perhaps then, I don't know, the way forward would for this cap indeed would be to do what Michelle says. I'm not sure whether that's what we will stick with long term, but I suppose for the initial implementation we can keep it simpler. And I'm more worried now about getting storage capacity tracking working. I'm a bit selfish here. That's the main pressing concern that I have. So if it helps to get this cap accepted, if we remove the CSI storage pool concept, then yeah, I'm fine with that. Because technically it's the same. It's the same information, just stored differently. So shall we agree on that? I'll do another revision.
I'll have to take a look. I will have to go back to take a look of the Christian's cap and see, if we just go back and without even introducing the storage pool, how that is going to address.
Yeah, I think
that would be good. Because I think if we really want to introduce a storage pool concept, then we need to make changes to the CSI spec too.
Yeah, I think that might be, that's maybe what we need to do. I think I need to take another look.
I think for the general purpose, we definitely need CSI changes. We already know that, for example, in the network attack storage case, we need another CSI call to give us that information, because it's not really discovered. Yeah, because you can't know which pools exist, what their topology is. You don't know what to call get capacity with. In that case,
you have the topology key from the drivers
for the nodes. Yeah, that's a mistake that I made initially too, but that just tells you where the node is. That doesn't tell you whether the storage is in that same topology or is more relaxed and it can be is at a higher level. For example, the storage might be in a data center, but the node is in a data center, in a rack, in a certain slot, whatever. So the topology of the nodes is typically more specific than the topology of a network attached storage system or a storage pool.
I think the way that we've implemented topology today is we assume the storage system topology matches the topology of the node. So like if you have a zonal volume, the node topology key that it's going to return is the zone that the node is in.
Yeah, for the volume. That's true. But then the node itself is more specific. So the node might have another key that says rack number 10. And that key will be missing for the corresponding volume. And therefore, if you look at the information that you have, if you don't have any volumes in the system, all you have are the storage topology of the topology keys from the individual nodes. And then, of course, you can call get capacity with every single combination of those keys, but for a storage system that actually isn't local to that node, you will get the same answer multiple times. And then you don't know that this is actually the same pool. So you do get information per node, but it will be duplicated multiple times.
Well, you would only call it with unique keys.
Yeah, but you don't. How do you know?
All right, so if you have multiple nodes in the same zone, you would only call the get capacity once per zone.
But how do you know which keys are relevant and which ones are not for the
You
storage
just
pool?
call all of them with the keys that they report.
For every single node.
Yeah.
And yeah, that's what I'm saying. You then get multiple different information. It's
Well,
doable.
so for network stuff, you don't call it per node, right? You call it per controller.
For networks, but all you have is the topology as defined for the nodes. And do we then iterate over all of that and combine it with storage class parameters? Is that what you're proposing?
Potentially, yes.
Yeah.
So say your key is zone, right? And you iterate over all the nodes and you get all the zones basically in your cluster. And then you call per zone per.
Yeah, but suppose you have a key that is zone and you have another key that is rack or data center. For the nodes, you have zones and data center set and potentially rack set for every single node. How do you know that it's enough to iterate over the zone key? The zone key doesn't for the external.
You would have to iterate over the combination of all the keys that it returns.
So basically you take all the values that you get for every single node and you iterate over those. And then if CSI driver actually doesn't care about the data center or the rack key, it will basically ignore that in the get capacity response and you just get the same information multiple times. Right?
Potentially.
Yeah. I'm fine doing it that way. My only concern is that it's not going to be very efficient because you could get away in that case with less objects in the API server. Instead of one object per node, it might be one object per zone, for example. So in a sense, that's an optimization.
If a storage system like reported a topology key with a lower granularity, I mean, that means that the storage system cares about that lower granularity.
Okay, so yeah, but that may be true. So in other words, we assume that the granularity that is set for the nodes is the level of detail that the system cares about. Yeah, that makes sense. Yeah, but actually, I think then we don't need some separate entity for CSI storage pool at all for this cap here.
Sorry, can we walk through a concrete example here? So if I have a storage system, a storage pool that I can have two different storage classes on, one that says I'm going to do no replication, one that does 3x synchronous replication. So they consume volumes differently, but they're consuming from the same storage pool. How would it work in this
So the first step is identifying the different topologies. And the proposal that I think what Michelle and I now agree on is that we just look at the pods, at the nodes, and the topology keys that are set for them. Okay. You basically do a union, and you end up with n different topologies. For each of these topologies, you then iterate over the different storage classes that are defined for that driver. And you do a get capacity call with each topology and every storage class parameter that is defined in different storage classes.
Okay,
and
so this is assuming that we extended get capacity to accept topology information?
It does.
Okay.
It already takes that.
Mm-hmm.
So that's the current get capacity call. It has topology and parameters. And we will then get an answer back from the CSI driver that in this topology, with these parameters, you have this capacity. The question then is, what does that capacity really mean? It is a bit underspecified, in my opinion, in the CSI spec. And I suspect that people just haven't really thought much about that yet, because they just report something, and I'm not sure whether anyone actually uses that information. So in this cap here, I'm basically distinguishing two different interpretations of that get capacity value. One is that the CSI driver really knows about limitations and what the maximum volume could be given these parameters, and returns that information. So get capacity returns basically the maximum volume size that can possibly be created, or can potentially be created in the current situation with these parameters. That would be the ideal situation for this usage here. So we would have to encourage CSI driver developers, if they want to use their storage capacity tracking, to do it that way. The other interpretation is that the driver just sums up all the available space. That's a higher value, and it doesn't guarantee you that you actually could create such a volume. If you have fragmentation, that might not work. So my API proposal was to have both values in the Kubernetes API. I think Michelle wanted to reduce that to 1, which is okay. I guess we can do that for the alpha, and if we have a better way of actually populating that information, we can extend the API later. I haven't done it that way because I wanted to avoid API churn. I think it's realistic that we will have to extend get capacity so that the return values are more precise, that we actually can tell from the response whether it's total volume, total capacity, or maximum volume size that we are getting from the CSI driver. And then, yeah, if we know that we are going to ask for that in the CSI forum or for the CSI spec, then I wanted to have the API ready to handle that and represent
But
both.
I guess we don't, my question is like, we're not using that information differently in Kubernetes.
Okay, so you are arguing we should only record maximum volume size and do our best to provide that information. Yeah, might be true. That
like
is,
if we actually have something in Kubernetes where we treat those two scenarios differently, then it would make sense to distinguish it in the API. But if we're going to treat both values the same way, I don't see a need to have two fields.
Yeah, my concern here is that if we say in the API object itself that we have a maximum volume size, or whatever we call that field, if we just call it capacity, what do we call it? Do we call it just capacity? Do we call it maximum volume size? Or do we call it total capacity? What would you choose?
To align with the current CSI spec, I believe it's called available capacity.
Yeah, and that's where I'm unhappy about the CSI spec, because it's ambiguous. And we are basically replicating that mistake, in quotation marks, in Kubernetes, in the Kubernetes API. And
so
if we
what is,
later,
What is the capacity? Is that the remaining capacity for the
that's exactly
the volume claim,
yeah,
the persistent volume, or the actual volume that's mapped to it?
It's exactly that part that hasn't been defined. The CSI spec just says you get capacity information back. It doesn't have any specific definition of what the semantic is that the CSI driver should, or that is attached to that value. It's basically ambiguous, which makes it very hard to use it for something specific. You can basically report it out to the user and then let the user figure out what that value means, perhaps by looking up in the CSI driver documentation what that particular driver returns. But for something that is used in Kubernetes, for example, to do a comparison with volume size, yeah, we have to make guesses in Kubernetes.
So at least on the Kubernetes side, capacity refers to the capacity the user can use. So it doesn't refer to how much physical capacity is actually taken up in the storage backend.
Yeah, so it's more related to volume size, and that's what we want to compare against.
So the spec today says in CSI for get capacity response, it's the available capacity in bytes of the storage that can be used to provision volumes.
Yeah, but that's
aligned with. Sorry, go ahead.
But does that mean that you can use that amount if you do one volume or that size? Do you have a chance to actually use that space in one volume, or can you only use it if you create multiple small volumes?
The way I read it is that it's for provisioning. I don't know. I guess it doesn't say provisioning a single volume or multiple volumes.
Yeah, it's exactly. I think it's ambiguous. It might end up that you can only use that space if you actually create multiple small volumes. But if you try to do that with one large volume, you can't because of fragmentation. If it helps to get the cap accepted, I'm fine with having just a capacity field and just copy what we get from CSI. But I think at some point, if we clarify what the exact semantic is, we might have to rename that field in the API, in the Kubernetes API, because then we have more specific knowledge about what the actual semantic is, and then just calling it capacity. Yeah, we could do better than that at some point.
I mean, I think this clarification doesn't necessarily have to be in the field name. It could just be in the comments of it.
Yeah, but then you don't know exactly when you just look at an object which semantic it had when it was created. So I think it will remain ambiguous. But yeah, let's just have one capacity field and say that we assume that this field can be compared against a single volume size, and then figure out whether we want and can enhance on that later on. Together with an extension of a CSI spec, I think, where we either clarify the spec or extend the get capacity response so that the driver, for example, can return both.
Can we walk through the topology use case one more time again? So you have, I'm sorry, I'm slow this morning. You've got, you've got a couple of storage classes using a single pool. You're going to have a pod that is, sorry, at what time are you going to do the calculation?
So there's no calculation in Kubernetes.
Okay.
CSI, the idea was to have one CSI storage pool per node topology. Why do I still have nodes here? But I thought I had removed that. Anyway, the idea is that you have topology as attached to the CSI storage pool. You do get capacity calls with that topology for every single storage class, and you just record that capacity. So basically, the capacity that is stored is what you get from get capacity.
Okay.
And you just record that. no calculations whatsoever. What then happens in the volume scheduling code is that it matches the node, the topology that it has for the node that it's currently investigating against those storage pools, the topology that you have recorded earlier. It looks at those storage pools that where the topology matches and where the storage class also matches. And if that combination tells you, yeah, the capacity is large enough for the current volume that we are trying to provision, then that node is suitable. And
so that so far makes sense. And if we collapse this down into a single storage class object, storage class already has node topology, I presume.
It's no, we still need we then have an object that has node topology and storage class name, and we still do the same check. We basically look for one of those objects where topology is suitable, storage class matches, and the capacity is large enough.
When does that happen? That happens at cluster startup?
It happens each time the volume scheduling library is called. It has a filter function. A filter function that looks at the volumes of a pod and tells back to the scheduler, these are the nodes where we can provision the volumes that don't exist yet.
Okay.
And that code gets extended to not just look at topology, but also consider capacity. Currently, it only checks the topology.
But you're saying that it's not going to be called pool, but it could be something else, the new struct?
The new struct then would, yeah. So that's the open question that we had. Do we keep the CSI storage pool concept or not? If we do keep it, yeah, it looks like you see here now, storage pool has the node topology and has different instances of the CSI storage by class. If we flatten it, we just iterate over more objects. The information conceptually is the same.
Yeah, I mean, if we have a one-to-one mapping, then having a separate object has little value because you could always take that struct and stick it inside the existing object.
Well, I
yeah,
think
so
the thing is that storage class is not a per topology object, right? Whereas capacity needs to be storage class per topology.
Right, but I think what's being proposed here is now identify what topology is going to be used at a workload runtime, and then go and iterate through all the storage classes that would fall within that topology, and then do the calculations on all of them?
Yes.
Okay.
So basically data population happens periodically, or when some entity external provisioner, was my proposal, notices that capacity has changed. So for example, provisioning a volume could trigger that check. And then this object gets updated with more accurate information that represents the current state. That's the data gathering phase. And that happens independently of using this information. Using this information happens in Kube Scheduler when there is a pod with certain volumes where these volumes use a certain storage class and we are looking for a suitable node.
Okay, time check. The normal SIG meeting's starting now, so I think we need to end here for today and continue again.
Yeah, so I think if we are flattening it, I think we still need to have this some struct. Otherwise, I think we still have this problem. I mean, that's in this other cap that we could have like exponential number of storage classes. So yeah, I think we need to have a follow-up meeting. I also go back and take a look at that one, and then we need to discuss more.
Yeah, I'll hold off making changes to the CSI storage pool until I hear back from Xing and VMware. Well, that is actually something that's acceptable for them. But I'm now stuck here between two different fronts, and I don't want to choose. So I would prefer to have that being hashed out among yourself. And
you can still make progress on this other the generic inline volume one, right? That you can.
I can do that. I can also clarify the thing that Michelle brought up about how to identify topologies. I'll update the CAP to include this assumption that we make about granularity of the different nodes. So I can make some progress, but it looks like CSI storage pool, yes or no, is one of these blocking questions that we need to hash out.
Okay.
Yeah.
All right. Thank you. I
Okay,
will
thanks.
stop recording and then join again so we can start the other one. Thanks.
Yeah.
Bye.
Bye.